Hello friends, this is Sanjay. In today's video, I will be covering the paper 1 mathematics questions from the January 2021 previous question paper. In this video, I have explained and answered all the questions in English. If you are more comfortable with Hindi, there is a separate video where I have covered the same questions in Hindi language. So you can watch that video. So let's get started with the questions. Which of the following is least likely to impact teaching and learning in mathematics? Now what the question is telling us that all of these options will have some impact. However, we are supposed to identify which will have the lowest or the least impact. The first option is knowing ways in which assessment affects the confidence of the learners. Now when you give a test or an assessment in your class, the purpose is for the students to understand what they have learned and for the teacher to understand how well the teaching is progressing. However, if the assessment is affecting the confidence of the learners, then the teacher should know about it. Therefore, knowing ways in which the assessments or the tests are affecting the confidence of the learners either positively or negatively will have a high impact on teaching and learning. Therefore, this cannot be the answer choice. The second option is providing complete solutions to students' wrong answers. Now, this providing complete solutions is something that is done by guidebooks or even by the answer keys. Therefore, as a teacher, if you are just providing complete solutions, then you are not adding much of a value because the students know what is the correct answer, but they don't know where they are going wrong, what is the concepts that they should understand. Therefore, if it is done completely on a standalone basis without any additional teaching, then providing complete solutions will have the least impact, and this is the answer choice. Let's also look at the other options. The next one is enhanced quality of feedback. Now, if you give the students complete solutions and you also sit with them and you make them understand where are they committing the mistakes, what is the concept that they should have understood, what is the approach that they should have taken to solve the problem, then you are providing them with enhanced quality of feedback. So this will have a high impact. Therefore, this cannot be the answer choice. And the last one is using the results of assessment to modify teaching. Now, if you give an assessment or a test in your classroom and you see that a lot of students are struggling with the basics. So you now understand that the students need to be taught the basics or the basic concepts again. Therefore, you modify your teaching and you maybe add some additional classes or you specify what are the concepts that students need to be learning. Therefore, you are using the results of the assessment to modify your teaching. Therefore, this will have a high impact. Therefore, this also cannot be the answer choice. Rohit realizes that a square is both a rhombus and a rectangle. He is at what stage of Van Heel's visual thinking? To answer this question, we first have to understand what are these different levels. Now, level 0 is recognition, where the student is able to identify the shapes on the basis of their appearance. Level 1 is where the student is able to analyze the different shapes on the basis of their properties. Level 2 is talking about relationships, where the student is able to identify the different shapes and understand the relationship between different types of shapes. And level 3 is talking about deduction, where the student is able to understand the properties and prove theorems on the basis of his understanding. And level 4 is talking about rigor, where the student is able to establish theorems and also do the correlation between different postulation systems. Therefore, if we look at what has Rohit been doing here, he has identified that this is a square. Therefore, he has crossed level 0. He is able to analyze the properties of a square and the properties of a rhombus and the properties of a rectangle. Therefore, he has crossed level 1. And he is able to identify that a square can be a rhombus and it can also be a rectangle. Therefore, he is able to identify the relationships between different shapes. Therefore, he has crossed level 2. Now, there is no talk of any theorems in this question. Therefore, we can ignore level 3. And there is no talk of any theorems or postulates in the question. Therefore, we can ignore level 4 as well. So, Rohit is currently at level 2. Therefore, the answer is level 2, relationships. The sum of any two whole numbers is a whole number. This property of whole numbers is referred to as which of the options? To answer this question, let's first understand what are these different properties of whole numbers. Now, the associative property can be explained like this. If you are trying to add A and B and C, it doesn't matter if you add B and C first and then add that sum with A, or you can add A and B together and then add their sum with C. The answer will be same. Similarly, if you are trying to multiply A and B and C, it doesn't matter if you first multiply B and C and the product is multiplied with A. Similarly, if you multiply A and B and multiply that product with C, the answer will remain the same. And this is associative property, where the numbers can be associated in any manner. Distributive property is where if you are trying to multiply A with B plus C, then you can first multiply A with B and add the product with A into C. That is, you are distributing A across the two sides. Therefore, this is distributive property. Now, closure property is where if A and B are whole numbers, then their sum will be a whole number. And if A and B are whole numbers, their product will also be a whole number. And this is closure property. Now, commutative property is where if you are trying to add A plus B, then it doesn't matter if you interchange A and B. That is, if A moves into B's place and B moves into A's place, that is, A and B can commute or travel. Similarly, A into B will be the same as B into A. Therefore, when we look at what has been given in the question, they are saying that the sum of any two whole numbers is a whole number. This is essentially closure property. Therefore, the answer here will be closure property. Which of the following statements regarding mathematics teaching and learning is incorrect? Therefore, we have to identify which of these options is incorrect. The first one is mathematical knowledge can be created in primary class students through observation of patterns and generalizations. This is a correct statement, because if you look at how students can be taught mathematics in a primary class, if you give them a pattern like this is one stick, this is two sticks, this is three sticks, then what comes here? They are able to look at this pattern and identify that since the number of sticks is increasing by one every time, there have to be 4 sticks here. So such pattern recognition can help in improving or in inculcating mathematical knowledge. So this cannot be the answer choice here. The next one is argumentation and negotiation play an important role in creating mathematical knowledge. This is also a correct statement, because if you look at how children play, they involve a lot of argumentation and negotiation. For example, a child might say, if you give me 1 pencil, I will give you 1 chocolate. But if you give me 2 pencils, I will give you 3 chocolates. So there is some argumentation and negotiation that is going on, and that helps the children in understanding what is the value of this product in comparison with the other products. What is the value of a pencil in comparison with the value of a chocolate? Therefore, argumentation and negotiation play an important role. So this cannot be the answer choice here. And mathematical learning is a social process involving dialogue. This is also a correct statement, because if you teach a child 10 minus 5 is 5, then you have just taught the child the concept. But if you give the child 10 rupees and ask him or her to go to a shop and buy a product for 5 rupees, then the shopkeeper will deduct 5 rupees and give back change worth 5 rupees. Now the child knows that 10 rupees is essentially 5 and 5. And if he gets a product for 5 rupees, then he will get only 5 rupees change. So such social process, which involves dialogue with the shopkeeper, enhances mathematical learning. Therefore, this is also a true statement, so that cannot be the answer choice here. The last statement is culture and context has no role in constructing mathematical knowledge. So this statement is incorrect. Therefore, this is the answer here. The reason is, if you look at how mathematics developed in ancient Rome, they were writing numbers like this is 5, this is 6, this is 10. They did not have a concept of 0, and they were not using a concept of decimal point. Now, the way in which mathematical knowledge developed in ancient Rome, because of their culture and the context in which they were writing numbers, was different from how mathematical knowledge developed in India, where we were using 0 and decimal points. Therefore, culture and context has an important role in construction of mathematical knowledge. Therefore, if we are asked to identify which is incorrect, then if we say this has no role, then this will be an incorrect statement, and that is the answer here. Which of the following statements is or are true regarding teaching numbers at a primary level? So you have to pay attention to the fact that you are talking about primary level kids here. Now option A is intuitive understanding of numbers should be encouraged. This is a correct statement, because if a child is holding one pencil in each hand and you tell the child that now you are having 2 pencils. Now next time that the child is holding 1 apple in each hand, then the child intuitively understands that he has 2 apples, because if he held 1 pencil in each hand, then if it was 2 pencils, then 1 apple in each hand will be 2 apples. Therefore, such intuitive understanding should be encouraged, and this is a correct statement. Now, writing numbers should be taught in sequence. This is incorrect, because some children may learn to write 8 before they learn to write 5. They may learn to write 9 before they learn to write 7, because it depends on how well the child is practicing writing and what are they comfortable with. Therefore, it is not necessary that they should learn to write in the same sequence as 1, 2, 3, 4. They can learn writing in any sequence. Therefore, this is incorrect statement. Statement C is writing numbers as numbers should proceed counting. This is also incorrect, because if you look at children, they learn counting before they can learn writing. Therefore, writing of numbers as numerals should proceed counting is an incorrect statement. Next is option D, that is order irrelevance of numbers should be encouraged. This is a correct statement, because when you look at how children count, if they have to count 5 sticks, they can count from the left or they can count from the right, and the answer will be same. It will still be 5 sticks. Therefore, it doesn't matter from which side they are counting. So this order irrelevance of numbers should be encouraged. So that is a true statement. Since A and D are correct, option 1 will be the correct answer here. Which of the following is the most important aspect of teaching of mathematics at a primary level? So we are talking about primary level children here. The first option is preparing for higher education and employment. We are talking about primary level kids. We are teaching them the basics of addition, subtraction, numbers. Therefore, preparing them for higher education and employment is definitely not the most important aspect. Therefore, this can be discarded. Now, promoting and preparing for technology. Now, again, primary level children, you are teaching them the basics. You are not preparing them for technology. Therefore, this is also incorrect. Making mathematics part of children's life experiences. This is a correct statement. And even the National Curriculum Framework also talks about the need to make mathematics part of children's life experiences. For example, if you teach a child that 10 minus 5 is 5, then you are just teaching some concepts. You are teaching them theory. But if you give them 10 rupees and if you send them to the market and if they buy something and if the shopkeeper takes 5 rupees and gives them 5 rupees change, then this life experience where they have actually bought something with money and they have understood the concept of money and the concept of subtraction and the concept of change. So this is what making mathematics part of life experience is all about, and this is a correct statement. And the fourth option is developing rigor in calculations. Again, we are talking about primary children here. They are trying to understand the concept. A rigor in calculations can come much later. Therefore, this is an incorrect statement. Which of the following statements is not correct with regards to the nature of mathematics? So the first statement is primary level mathematics is concrete and does not require abstraction. This is an incorrect statement. Therefore, this is the answer here. The reason is in primary level, there is a lot of abstract concepts that are used. For example, if the child is holding 2 pencils, 1 in each hand, then this is an abstract concept that you are using to teach numbers, right? Because if you tell the child, if you hold 1 pencil in each hand, then you have 2 pencils. Therefore, this is an abstract way of teaching concrete numbers. Therefore, primary level mathematics is not concrete. There is a lot of abstraction. Therefore, this statement is not correct and this is the answer here. Now, let's look at the other options. Mathematics uses special vocabulary to communicate ideas precisely. This is a correct statement because in mathematics, we use vocabulary like addition, which essentially means that you should put together 2 and 2 and 2 and 2. So if I tell you add 2 plus 2, 2 plus 2, so then I'm using that word addition to communicate precisely what is it that you should be doing here. Therefore, mathematics uses special vocabulary. Next, argumentation skill is important in construction of mathematical knowledge. Again, when you look at how children play, they argue a lot with each other and they negotiate a lot. Such as if you give me 1 chocolate, I'll give you 2 pencils, or if you give me 2 biscuits, I'll give you 1 pencil. So this argumentation skill is important in construction of mathematical knowledge and in understanding what is the value of things in comparison with other things. Therefore, this is a correct statement. The last one is mathematical concepts are hierarchical in nature. This is also a correct statement. For example, you teach children addition first and then you teach them multiplication, because multiplication is repeated addition. Therefore, mathematical concepts are hierarchical. So they follow a particular pattern. Therefore, this is also a correct statement. Which of the following activities is most likely to develop spatial reasoning among students? Now, what is the spatial reasoning? An example for spatial reasoning might be when you go to a shop and you look at a sofa and you want to buy it. But by looking at it, you are able to imagine or you are able to visualize whether this sofa will fit into the space that you have in your house. So you are imagining the sofa and mentally placing it in the space in your house. So this reasoning, this imagination that you are using here is nothing but spatial reasoning. So now let's look at the activities that have been given in the options. The first one is identifying tessellating figures. Then there is drawing of bar graphs, then identifying patterns in a number chart, and then Sudoku puzzles. So now if you look at what are these activities, number chart will help you in identifying patterns. That is, all these numbers are increasing by 1 and all these numbers here are ending with 0. So such patterns can be recognized in a number chart, but spatial reasoning might not come into play here. Right? And Sudoku puzzles will make you very good at addition and subtraction, but not at spatial reasoning. Therefore, this also can be discarded. Bar charts are good for helping you represent numbers in the form of pictures. And you can represent the same number in different types of bar charts depending on what kind of scales you use on the x and y axis. Therefore, this is not specifically helpful in spatial reasoning. So this also can be discarded. Now these are tessellating figures, where you take a figure and you repeat it multiple times without any gap. This is a tessellation of squares and this is a tessellation of triangles. Now if you ask a child whether this pattern will fit into this sequence or this sequence, then the child will be able to identify this. So this tessellating figures and activities using tessellating figures will help the child in develop spatial reasoning. Therefore, this is the correct answer here. Which of the following is most suitable for teaching children the concept of fractions? Now this question is telling us that some of these options may be useful for teaching fractions, but which one is most suitable is what we need to identify. Let's look at what these options are all about. Now, this is an abacus. Abacus is useful for teaching calculations, addition, subtraction, but for teaching fractions, this may not be specifically useful. So this can be discarded. Now, a number chart can help children in understanding what patterns are all about. For example, in this line, all the numbers are increasing by 1. In this line, all the numbers end with 0. Therefore, number charts may not be useful in teaching about fractions. So this can be discarded. Now this is a geoboard. A geoboard is nothing but a wooden board or a plastic board in which a lot of nails or pegs are stuck, and rubber bands or threads can be used to draw different types of geometric patterns. So this is useful in teaching concepts of geometry and not fractions. And these are Cuisenaire rods. So Cuisenaire rods are wooden rods which are of different lengths, and these are useful in teaching fractions. For example, 1 is probably half of 4 or 4 is half of 8. So such fractions can be taught using Cuisenaire rods. So among the given options, Cuisenaire rods is the correct answer because it is helpful in teaching children the concept of fractions. In which of the following statements the number 3 is used in an ordinal sense? Now numbers can be used in a cardinal sense or in an ordinal sense. Now when we are counting something such as 1, 2, 3 or 4, then we are using the numbers in a cardinal sense. So counting is cardinal. And if we are using the numbers to describe orders, for example, first, second, third or fourth, then we are using the numbers in an ordinal sense. So if it is order, then it is ordinal sense. Now let's look at the answer choices. The first one is all groups have 3 team members. Here 3 is just a count. Therefore this is cardinal usage. This box contains many sets of 3 pencils. Again 3 is just a count, so cardinal. I live in the 3rd floor of this building. So 3rd is an order. Therefore this is where 3 is used in an ordinal sense. So this is the correct answer. The next option is this house has 3 rooms. So 3 again is a count. So cardinal. Therefore this cannot be the answer here. Identify the correct statement. The first statement says that the units of perimeter and area are same. this is an obviously incorrect statement because the unit of perimeter will be centimeter or inch or meter, whereas the units of area will be square centimeter or square inch or square meter. Therefore, the units are different. This statement is incorrect. The next three statements, to explain them better, I have drawn three figures below. The first one is a square of 2 centimeter into 2 centimeter. Therefore, the area of this square is 4 square centimeter and the perimeter will be 2 plus 2 plus 2 plus 2. So it is 8 centimeter. And then there is a rectangle of 1 centimeter into 4 centimeter. Therefore, the area of this will be 4 square centimeter and the perimeter will be 4 plus 4 plus 1 plus 1. So it is 10 centimeter. And then there is a rectangle of 2 centimeter into 3 centimeter, which is 6 square centimeter in area, and the perimeter will be 3 plus 3 plus 2 plus 2, so 10 centimeter. Now let's look at the three statements. The last statement says if two figures have the same perimeter, their areas are equal. Now if you look at figure 2 and figure 3, both of them have the same perimeter, which is 10 centimeters, but their area is different. This one has 4 square centimeter and this is 6 square centimeter. Therefore, even though the same perimeter, it is not necessary that their area will be equal. So this statement is incorrect. And if two figures have the same area, their perimeters are equal. Now look at the first and the second figures. The first figure has an area of 4 square centimeter and the second figure also has an area of 4 square centimeter. But their perimeter is different. The first figure has 8 centimeters and the second figure is 10 centimeters. Therefore, if two figures have the same area, their perimeter need not be equal. So this statement is also incorrect. And if you look at all the three figures, you can see that depending on the shape of the figure, the perimeter will change. Therefore, the shape of the figure determines the perimeter. So this is a correct statement. Identify the correct statement with respect to mathematics curriculum. The first statement is the concept of negative number should be introduced at a primary level for better understanding. Now at a primary level, you are still teaching children the basics of numbers, counting, addition, subtraction. So if you introduce negative numbers, that leads to unnecessary confusion. Therefore, this is an incorrect statement. The next statement is the concept of area measurement should be introduced only at an upper primary level. This again is incorrect because the concept of area measurement is already introduced at a primary level. For example, if you are asking children to measure a paper by using their hands, how many hands can you place on this paper? So that is a concept of area measurement which is already introduced at a primary level. Therefore, this is an incorrect statement. Next, the foundation of algebraic thinking can be laid at a primary level. This is a correct statement because algebraic thinking doesn't necessarily mean a square plus b square and concepts like that. It can be about representing numbers in the form of objects or things or symbols. For example, if you teach a child that an apple is equal to 2 chocolates, then you are essentially teaching what is the relationship between an apple and chocolates and what is the kind of exchange that can happen. Therefore, such concepts are the foundations of algebraic thinking and these are already laid at a primary level. Therefore, this is a correct statement. The last one is the concept of fraction should be introduced only at an upper primary level. This is an incorrect statement because the concepts of fractions are already introduced at a primary level. For example, you are teaching children that 1 rupee is actually 2 50 paise coins, or that 1 hour is essentially 2 30 minutes. Therefore, such concepts are essentially fractions and these are already being taught at a primary level. Therefore, this statement is incorrect. Identify the correct statement with regards to introducing the concepts of triangles at a primary level. Now, the first statement says children should be exposed to triangles of all types, but exposure to other figures should be avoided. This is an incorrect statement because when you are introducing children to various shapes, you are introducing them to triangles, to squares, to rectangles and to circles. Therefore, why is it that you should expose them only to triangles of all types and not to other figures? Therefore, this is an incorrect statement. The next statement is children should be exposed to triangles of all types and also to other figures. This is a correct statement because you are introducing them to all types of geometrical figures. And the third statement says definition of a triangle should be provided first. At a primary level, you are just trying to get them to identify the different shapes. So definition of a triangle can wait till they are much older. Therefore, this is incorrect. And the last statement is children should be exposed only to equilateral triangles to avoid confusion. This is an incorrect statement because a triangle is a triangle for a small child. If it has 3 corners and if it has 3 sides, then that is a triangle, and you don't have to expose them only to equilateral triangles or not to scalene triangles or not to isosceles triangles. So this is an incorrect statement. In a division sum, the divisor is 5 times the quotient and twice the remainder. If the remainder is 5, what is the number? So to solve this problem, let's write it down in the form of a normal division sum. So if we write it down like this, we know that the remainder is 5, so let's put 5 here. And we know that the divisor is 5 times of the quotient and twice the remainder. Therefore, if we multiply the remainder with 2, then we'll get the divisor, which happens to be 10. And the divisor is 5 times the quotient. Therefore, if we divide the divisor by 5, we'll get the quotient, that will be 2. And since 10 twos is 20, we can put that there, and there should be a number here such that this number minus 20 will result in 5. Therefore, it should be 25 here, and that is the correct answer. The sum of 5 consecutive numbers is 20. What is the sum of the first 3 consecutive numbers in this sequence? So let's use a simple algebraic method to solve this problem. Let the first number be x, and the next number will be x plus 1, and the next number will be x plus 2, then it will be x plus 3, and then x plus 4, and the sum of all these numbers is 20. Now if we add the total number of x's here, we see that it will be 5 x's, and if we add these numbers together, we'll see plus 10, and the total is 20. Now 5x is equal to 20 minus 10, because we have moved the 10 this side, and 5x will be 10. Therefore, x is equal to 10 by 5, that is equal to 2. So which means that the first number is 2. So if the first number is 2, then the next number is x plus 1, so it will be 3, and then x plus 2, so it will be 4, and x plus 3, it will be 5, and x plus 4, it will be 6. And if we add all of these together, we'll get 20. What is the sum of the first 3 consecutive numbers? So 2 plus 3 plus 4 is what we need to add. So 2 plus 4, 3 plus 4 is essentially 9. So 9 is the correct answer here. A wire in the form of a square encloses an area of 144 square centimeter. How much area is enclosed if the same wire is bent in the form of a rectangle of length 16 centimeters? So first we have to find out what is the length of this wire. So now we know that this wire has been bent in the form of a square, and this square is actually 144 square centimeters, which means that the lengths of the sides, that is the sides, will essentially be the square root of 144. So the square root of 144 is 12. Therefore, each side is 12 centimeter. Since we know that each side is 12 centimeter, the perimeter of this square will be 12 plus 12 plus 12 plus 12. So that will be 48, and that is the length of this wire. Now, if the same wire were to be bent as a rectangle of 16 centimeter, then we see that if we write a rectangle like this, and one side is 16 centimeter, then the opposite side will also be 16 centimeter. Now we have to find what is the length of the other two sides. So we know that the length of that wire is 48, since 16 and 16 are already here. So let's add 16 plus 16, that will be 32. So minus 32, we get 6 and 1, so 16. So now the other two sides must be 16 divided by 2, therefore 8 and 8. Therefore, the area of this rectangle will be 8 into 16, and that will be 128 square centimeter. Therefore, that is the correct answer. Amongst the following fractions, the largest and the second largest fractions respectively are which ones? Now, there are multiple ways of solving this problem. To compare all of these fractions, we can use the LCM method, or we can use the decimal method, or we can use the percentage method. Since the fractions that are given are quite simple, we can use the percentage method and solve this quite easily. To use this, all we have to do is multiply each of these fractions with 100. Now, if we multiply half with 100, we will get 50. So let us write 50 here. And if we multiply 3 by 4 with 100, we'll get 75. So that will be 75 here. And if we multiply 3 by 5 with 100, we'll get 60. So let's put 60 here. And 2 by 3 into 100 will be 66.66 something. And similarly, when we multiply 5 by 6 into 100, we'll get 83 point something. So now it is easy to compare all of these fractions. We know that the largest is 83, which is 5 by 6. And the second largest is 75, which is 3 by 4. Therefore, the correct answer is 5 by 6 and 3 by 4. Asmita reaches school for a meeting 15 minutes before 8:30 am. She reached half an hour earlier than her colleague, who is 40 minutes late for the meeting. So what is the scheduled time of the meeting? Very simple problem. Let's start writing down each of the bits of information that is available. So Asmita reached school 15 minutes before 8:30 am. Therefore, 8:30 minus 15 minutes. So Asmita must have reached at 8:15 am. She reached half an hour earlier than her colleague, which means that her colleague reached half an hour after Asmita. So colleague 8:15 plus 30 minutes. So her colleague reached at 8:45. And her colleague is 40 minutes late for the meeting, which means that the meeting started 40 minutes before her colleague arrived. Therefore, the meeting would be 8:45 minus 40 minutes. That would be 8:05. Therefore, the meeting started at 8:05. In how many ways 48 small squares of 1 centimeter into 1 centimeter can be arranged so that the resulting area is 48 square centimeter? Now there is a small error in this problem. The error is that they have not specified what is the shape in which these 48 small squares should be arranged, because if they don't specify that, then these 48 squares can be arranged in literally thousands of different ways, and the sum of all of them, that is the resulting area, will still be 48 square centimeter. Therefore, all of the answer choices will be correct. For example, if I have 5 squares like this, so what is the total area of the squares? It is 1 plus 1 plus 1 plus 1 plus 1. So it will be 5. Now if I arrange these in the form of a line like this, so then the resulting square or the resulting area will still be 5 square centimeter. And if I arrange them in the form of a pyramid like this, even then the resulting area will still be 5. Therefore, these 48 small squares can be arranged in literally unlimited number of ways, and still the resulting area will be 48. Therefore, what they should have specified here is that in how many ways these squares can be arranged as a rectangle. Because when they specify that it has to be arranged as a rectangle, we know that the length into breadth is equal to 48. And we have to see how many different numbers can be put in this particular equation so that the resulting area is 48. For example, 1 into 48 is equal to 48, and 2 into 24 is equal to 48, and 3 into 16 is equal to 48, and 4 into 12 is equal to 48, and there is no multiple for 5, so 6 into 8 is equal to 48, and 7 doesn't form a multiple. Therefore, next we'll move to 8. So 8 into 6 is equal to 48. Now we can stop here, because you can see that 8 into 6 has already been taken here as 6 into 8, and everything after this will be repetitions. Therefore, we'll stop here and we will remove this. So how many combinations are we left with? 1, 2, 3, 4 and 5. So there are 5 different ways of arranging these 48 small squares so that the resulting area is 48 square centimeters, and 5 is the correct answer here. In a school assembly, students of a class are standing in a line, and Ruhi is 19th from both ends. So how many students are present in that class? Very simple problem. So what is being told here is that Ruhi is standing in a line and she is 19th from both ends, which means that there are 18 students after Ruhi and 18 students before Ruhi. So if we are asked how many students are present in the class, then it will be 18 plus 1 plus 18. So that will be 37. So that is the correct answer here. A number is larger than half of 100. It is more than 6 tens and less than 8 tens, and the sum of its digits is 9. The tens digit is the double of the ones digit. So what is the number? Now there is a lot of information given in this question, but let us start eliminating some of the answer choices using some of the easiest bits of information that is available. Now it says that the tens digit is the double of the ones digit. Now, which means that the tens digit and the ones digit. So the tens digit has to be the double of the ones digit. Now 54 doesn't fit the requirement, 81 doesn't fit the requirement, 72 doesn't fit the requirement, 63 fits the requirement. So this is the correct answer because 6 is double of 3. Therefore, this has to be the right answer. If you want to verify this, you can check the other information as well. For example, the number is larger than half of 100. So half of 100 is 50. So 63 is more than 50. Therefore, this is correct. It is more than 6 tens, which means that it has to be more than 60. So this also is correct. And less than 8 tens, which means that it has to be less than 80. So this also is correct. And the sum of its digits is 9 and sum of its digits 6 plus 3 is 9. And we also saw that the tens digit is double of the ones digit. So we have seen that 63 is the correct number. But we could solve this problem by just using one bit of information. That is, the tens digit is the double of the ones digit. So start with the easiest bit of information and start eliminating some of the answer choices, and you'll be able to shortlist the answer much faster than doing the complete calculation. The rates of various stationery items are given below. Sohail buys 1 packet of crayons, 2 packets of pencils, 1 packet of sketch pens, 1 scissors, 5 sheets of glazed paper and 1 pack of decorative stickers. How much would he be required to pay? Very simple problem. All that we have to do is multiply these rates with the number of items that he has bought and add it up, and we'll get the answer. So 1 packet of crayons into 1, so that will be 1550. Then 2 packets of pencils, so into 2, that will be 28. And 1 packet of sketch pens, so into 1, that will be 2250. And 1 scissors, so that will be into 1, so that will be 17. And 5 sheets of glazed paper, so that will be into 5, that is 1250. And 1 pack of decorative stickers, so into 1, that is 5. So when we add this up, we'll get 100.50. So that is the correct answer here. A train starts from Patna on 30th May at 23:40 hours and reaches Mumbai on 1st June at 5:15 hours. So what is the total travel time of the train? So what we have to remember here is that in May there are 31 days. So the train traveled on 30th May and also on 31st May and reached Mumbai on 1st of June. On 30th May it started at 23:40. So it would have traveled till midnight. So how much did it travel? It traveled for 20 minutes. And on 31st, since no information is available, we can assume that it traveled for the entire day. Therefore, it traveled for 24 hours. And on 1st June, assuming that it started at 1 minute past midnight, it reached Mumbai at 5:15. Therefore, it has traveled for 5 hours and 15 minutes. So if we add this 5 hours, 15 minutes and 24 hours and this 20 minutes, we'll get 29 hours and 35 minutes. Therefore, this is the correct answer. In a 5-digit number, the digit at the hundreds place is 3/4 of the digit in the 10,000s place, and the digit in the tens place is 2/3 of the digit at hundreds place. The digit at tens place is square of the smallest prime number, and the digit at thousands place is the largest single digit prime number. If the digit in units place is the largest single digit odd number, then the number is what? Now, a lot of information has been given in this question, but this question can be solved by eliminating some of the answer choices with the easily available information. For example, it's a 5-digit number, so let's just put 5 dashes here so that we can start filling in the blanks. Now, let's start from the last bit of information, that is if the digit at the units place is the largest single digit odd number. So if we look at all the single digits, 5, 6, 7, 8 and 9, we see that the largest single digit odd number is 9. Therefore, the unit place has to be 9. We can eliminate these two answer options because they are ending with 7. And then let's move a little up, and it says the digit at the tens place is square of the smallest prime number. Now a prime number is a number that is divisible by itself or by 1, and the smallest prime number is 2. Therefore, the digit in the tens place is square of the smallest prime number. Therefore, 2 square is 4. Therefore, it has to be 4 here. Now, we see that this has 1 here. Therefore, this can be eliminated and we are left with only one choice where it is 49 here, and this has to be the correct answer. What should be subtracted from the sum of 8008, 8088 and 8808 to obtain 17863? Very simple problem. First, write down these three numbers, that is 8008 and 8088 and 8808, and if you add them up you will get 4, 0, 9 and 24. So if you subtract this number from this number, then you will automatically get the answer. So 17863. So if you subtract, you will get 1, 4, 0 and 7. So 7041 is the correct answer, which is here. A bucket of 16 liters capacity is filled to the brim with water. Water from this bucket is to be transferred into smaller utensils. A mug filled to capacity has to be dipped 50 times to completely transfer the water in the bucket into the utensils. What is the capacity of the mug? Now, since all the answer options are given in ml, let's convert this 16 liters also into ml. So 16 liters into 1000, because 1 liter is 1000 ml. So we'll get 16,000. Now we are being told that this mug has to be dipped 50 times. Therefore, we'll divide this by 50. And when we divide this, we'll get 320. Therefore, the capacity of the mug is 320 ml, and that is the correct answer here. A taximeter shows charges of rupees 50 for the first 2 kilometers of the journey and rupees 16 for every subsequent kilometer travelled. Manju pays rupees 258 as fare to travel from her house to the railway station. So how far is the railway station from her house? So how much has Manju paid in total? It is 258 rupees. So write down 258 here, and she has paid 50 rupees for the first 2 kilometers of travel. Therefore, write down 50 here because she has travelled 2 kilometers in this 50 rupees. So what is the balance? It is 208. Now for every subsequent kilometer after the first 2 kilometers, the taxi is charging 16 rupees per kilometer. Therefore, divide this by 16 and you will get 16 ones are 16 13. Therefore, it will be 13 kilometers. So the total distance that she has travelled is 15 kilometers. Therefore, the answer here is 15 kilometers, which is the distance from the railway station to her home. The following table shows marks obtained out of 100 by Maria and Shehnaz in 5 subjects. Based on the table above, identify the correct statement from among the following. Now, the first statement says that Shehnaz's aggregate marks in maths and science are more than Maria's aggregate marks in these subjects. So Shehnaz has scored 78 and 82 in maths and science. So this will be 160. And Maria has scored 88 and 90 here. So that will be 178. Therefore, Shehnaz's aggregate marks in maths and science are actually less than Maria's aggregate marks in these subjects. Therefore, this statement is incorrect. The aggregate marks of Maria and Shehnaz are equal. Now, if we add this, we get 390 and this also is 390. Therefore, this statement is correct. Now, we can stop here because we have arrived at the correct answer. But if you have the time, you can try evaluating the other two statements as well, and you will find that they are actually incorrect. Which of the following is a desirable teaching and learning practice in the context of mathematics? The first statement is open book tests should be avoided. Now, open book tests are tests where you can actually take your textbook or notes to the exam. Now, if you look at some of the top institutions like the IIMs, a lot of tests are open book tests because they are paying more importance to whether you have understood the concepts, whether you have understood the subject, and not whether you have just mugged up the entire textbook per se. Because if you know which textbook to open, which chapter to open and which formula to use, then it means that you have actually understood the subject. So open book tests can actually evaluate whether you have understood the subject and the concepts. Therefore, this should not be avoided, and this is an incorrect statement. And students should be told to follow the prescribed steps of solving problems. This is also incorrect, because if you teach the students the basic concepts correctly, then they can use their own steps to solve the problems. Therefore, it is not necessary that they should follow the same steps that are prescribed to them. Therefore, this is also incorrect. The third one is open-ended questions should be avoided to prevent confusion. Now, open-ended questions are questions which can have more than one correct answer. For example, if I ask you, how many sides are there to this image? So you'll say 4. So this is a close-ended question because there is only one possible answer. But if I ask you, tell me the name of any figure which has 4 sides, then you can say square, or you can say rectangle, or you can say parallelogram, or you can say rhombus, and all of them are correct answers. Therefore, open-ended questions have more than one correct answer, and open-ended questions can actually assess whether you have actually understood the concept or not. Therefore, open-ended questions should not be avoided. Therefore, this is an incorrect statement, and intuitive understanding of concepts should be encouraged. This is a correct statement. For example, if I teach a small boy that if you are holding a pencil in each of your hands, you have 2 pencils with you. The next time when the same child is actually holding 2 apples in each of his hand, then he intuitively knows that he is actually holding 2 apples, because the last time he was holding 1 pencil in each hand, it was 2 pencils. Now if he is holding 2 apples, 1 in each hand, then it has to be 2 apples. Therefore, this is intuitive understanding of the concepts and it should be encouraged. Therefore, this statement is correct. Following are some questions posed by the teacher in the mathematics classroom. So when we look at the answer choices, what we have been asked to do is identify which of these questions are close-ended and which one of them are open-ended. Now, close-ended questions can have only one possible correct answer, whereas open-ended questions can have multiple possible correct answers. Now let's look at the questions. The first one is, what is the area of the rectangle whose one side is 5 cm and perimeter is 30 cm? When we do the calculation, there can be only one possible correct answer here. Therefore, this is a close-ended question. The next question is, find a set of numbers whose median is 4. So if the median is 4, the set of numbers can be 3, 4, 5, or 2, 3, 4, 5, 6, or 1, 2, 3, 4, 5, 6, 7. So whether it is 3, 4, 5 or 2, 3, 4, 5, 6 or 1, 2, 3, 4, 5, 6, 7, the median will always be 4. Therefore, this question can have multiple possible correct answers. Therefore, this is an open-ended question. And the next one is, list all the prime numbers between 0 and 8. Now the prime numbers between 0 and 8 are 2, 3, 5 and 7. Now since we have been asked to list all the prime numbers, we have to answer this as 2, 3, 5 and 7. Therefore, this is a close-ended question. If we have been asked to list any of the prime numbers, then we could have said 2 or 3 or 5 or 7. So then that would have been an open-ended question. But here we have been asked to list all the prime numbers. So this is a close-ended question. The last one is, tell me anything mathematical information you know about rectangles. So now this is a question where you can talk about area, or you can talk about perimeter, or you can talk about angles. So there are multiple possible correct answers to this question. Therefore, this is also an open-ended question. Now, the first option says A is a close-ended and B, C and D are open-ended question. Now, A is close-ended. This is correct. And B, C and D are open-ended. This is incorrect because B happens to be open-ended, whereas C is close-ended. Therefore, this statement is incorrect. The next one is A and C are close-ended and B and D are open-ended. A and C, yes, A is close-ended and C is close-ended and B and D are open-ended. Therefore, this statement is correct. And A and B are close-ended questions and C and D are open-ended questions. This again is incorrect because B is not close-ended. And A, B, C are close-ended and D is open-ended question. This is also incorrect because B happens to be open-ended. With that, we have covered all the 30 maths questions from this previous question paper. If you have any questions, comments or feedback, please post them in the comment section below. Please do like this video and subscribe to our channel. And you can also share this video with any of your friends who are preparing for similar exams. So thank you, stay safe, take care, and I will see you again in the next video.